Okay, good morning, guys. Assalamu alaikum warahmatullahi wabarakatuh. So, today we'll be doing sort of a practice actually before your test 2. Because remember that the test 2, right, that'll be happening on 18th of December, we'll be covering from chapters 2 to 5. Okay, so what I've did here is I've taken random questions from each chapter. So this one is from chapter 2, and then this one here right here is from chapter 3. Okay, followed by a question from chapter 4. Okay, and of course chapter 5. Okay, so we're gonna go for like a walkthrough on these problems, right, and how we're gonna solve and approach them. So hopefully this will be very helpful for your test 2 onwards. Okay, so let's begin with this problem. So specify the magnitude and the coordinate direction angles alpha, beta, and gamma 1 of F1. So the resultant of the three forces acting on the brackets Fr equals to negative 350 k pounds. Note that F3 lies in the XY plane. Okay, so this is something to take note of and remember. So the first step we could do is try to express the forces in the Cartesian vector. So F1 in vector form is just, F1 cos alpha 1 I plus F1 cos beta 1 J plus F1 cos gamma I K. Okay, that's F1. Then for F2, it's negative 200, right, because it's going in a negative direction, so it's negative 200 J. Okay, and of course we know the unit is in pounds. All right, I forgot to highlight that, so don't forget to put your units. And F3, okay, quite simply it's negative 400 sine 30 I plus 400 cosine 30j. Okay, so this is obviously going to be in pounds. And you can of course simplify this vector right away, so it become negative 400 sine 30. So it becomes negative 200 I, and 400 cosine 30 will be 400 cosine 30 would be, so cosine 30 is what? It's root 3 over 2. So root 3 over 2. So 100 will be 200 over plus 200 root 3 J pounds. Okay, which is, just double check, yeah? Alright, perfect. So that's F1, F2, and F3. And we know that Fr is clearly negative 350 K pounds. And we also know that Fr, the resultant force, is basically the summation of all the three force vectors, F1 plus F2 plus F3. And of course, we can rearrange this by saying that F1 is equivalent to Fr minus F2 minus F3. Okay? So that's how you can get the F1 force vector itself. Okay, so let's just do that. So in this case, F1 is equivalent to, Fr is just negative 350, so it's just simply minus 350 K. Okay, minus F2 is, minus 200 J, so it's just, we're just gonna put here negative, minus 200 J. And F3, okay, minus also, so minus negative 200 I, F200 I plus 200 root 3J plus 200 root 3J. Okay, So if we take out the respective components in terms of I followed by the J components and last but not the least by K components, okay? So let's sort it out. So F1 should be 200I, okay? And in terms of J, it would be plus 200J minus 200 root 3J minus 350K. So F1 would be 200I plus 200 1 minus root 3J, okay, minus 350K, which should be, fairly logical, right? Yeah, makes sense. And of course, this would be in respect to pounds. Okay, so we already found F1's vector itself, but the question wants us to find the magnitude as well as the coordinate direction angles, right? Alpha 1, beta 1, and gamma 1. So if we equate it to the original F1 equation, we can say that F1 was what? Was F1 cos alpha 1I plus F1 cos beta 1J plus F1 cos gamma 1K, right? So yes, we can say that basically F1 cosine alpha is 200, F1 cosine beta 1, cosine alpha 1, yeah, is 200, 1 minus root 3, okay, and F1 cosine gamma is, well, negative 350, right? So the thing is, we will end up having, well, if you were to express F1, right, so we can say that F1 is equivalent to 200 over cosine alpha 1 equals to 200 1 minus root 3 over cosine beta 1 is equals to negative 350 over cosine gamma 1, right? So we can establish the relationship. That's one relationship actually between F1 because that's magnitude, right? Another relationship we can establish is that we know that alpha 1 squared plus beta 1 squared plus gamma 1 squared is equivalent to 1, right? So we know that relationship as well. Alpha 1 squared plus beta 1 squared plus gamma 1 squared equals to 1. So from these two relationships, we should be able to deduce the alpha, beta, and gamma actually, right? So yeah, let's see how can we do this. Let's think about it. Right, if we could go to 1. Actually, wait, I realize there's a much better way to solve this problem, right? Because yes, this is correct. All the stuff I said earlier is correct actually. But the far easier way is that we can easily find the magnitude of F1 itself, right? We can easily find the magnitude of the F1 itself, which is very straightforward. It's just the magnitude of the F1 vector, okay? And that'll give us the answer straight away. So we don't have to go to all this trouble, okay? We don't have to really go to all the trouble of this, right? And yeah, we know the magnitude of F1 vector is very simple. It's just simply 200 squared, just 200 squared plus 200 minus 200 root 3 squared plus negative 350 squared. So once we do the magnitude of the F1 vector, we end up actually getting the magnitude of F1 itself, which is basically what the question wanted, right? And yeah, which is going to be about 428.8775 newtons. So that means your F1 is just simply 429 newtons. So that would be your magnitude, right? And that's your answer for the first part. Now they wanted the coordinate direction angles, right? So for F1, they wanted the coordinate direction angles. So yeah, without further ado, we know that 200 over cosine alpha is equals to 428.8775, right? Then cosine alpha is equals to 200 over 428.8775, and alpha is equals to cosine inverse 62.2 degrees. So 62.2 degrees for alpha. And then for beta is just simply 200 1 minus root 3 over cosine beta, because beta 1, alpha 1, alpha 1, alpha 1. So beta 1 is equals to 428.8775, okay? Then cosine of beta would have been equals to 200 minus 200 root 3 over 428.8775, and then beta 1 would be equal to, if you do the cosine inverse, would be 200 minus 200 root 3. Yeah, it become 109.9, or basically you can say just 110.0 degrees, okay? You've rounded off actually, okay? That's beta. Actually, just 110. Oops, sorry, it was a big eraser there. So it's supposed to be, yeah, 110 degrees. You can just leave it like that. And then for gamma, right, let me just add another page. So we know that negative 350 over cosine gamma 1. So negative 350 over cosine gamma 1 is equivalent to 428.8775. And of course, cosine gamma is equals to negative 350 over 4. Okay, so it becomes negative 350 over 428.8775. Thus, gamma would be equal to, you do the cosine inverse of it, so 350 over 428.8775. You get 144.69 or 144.7 degrees, okay? And of course, you can write it as 145 actually, if you want one of the three significant figures, okay? So basically, we've already found a magnitude and we've found the coordinate direction angles as the question has expected us to do, okay? And yeah, that would be the answer itself. Yeah, that one, the magnitude and coordinate direction of F1, okay? So yeah, so it's a pretty okay problem actually. It's not a bad problem. It's just that sometimes, if immediately we got the vector, right, we can immediately find the magnitude, right, which will obviously lead us to the magnitude right here. And yeah, we can easily get the alpha, beta, and gamma straight away, okay? So that's about it for question 1. Let's move on to question number 2 from chapter 3. Okay, so question number 2 states, the unstretched length of a spring is AB is 3 meters. If the block is held in equilibrium position as shown, determine the mass of the block at D. Okay, so they want to find what is the mass of the block at D. Okay. So they've also given you the unstretched length of the spring, which is 3 meters, right? So the thing is, right, for the length AB, what is the current length here? Okay. How are we going to find the current length of AB? So for spring AB, okay, if we were to just draw this line right here, okay, between A and between B, okay, and we know the vertical height here is 3 meters, and here is 4 meters. Okay, so what comes to your mind is obviously using the Pythagoras theorem. So the Pythagoras theorem. So in this case, AB would have been equals to square root 3 square plus 4 square equals to 5 meters, right? So simple Pythagoras theorem. So we know that the stretched length of AB is 5 meters, right? So the stretched length is 5 meters. Unstretched length is 3 meters. So we know that the stretched length is 5 meters, unstretched length is 3 meters. Thus, the change in length, or the delta x, is just simply 5 minus 3, which in this case is 2 meters, which of course we know that it's of course been extended, right? The spring is undergoing extension, right? So therefore, force by spring A, okay, so force by spring AB actually, by spring AB is equals to what? So FAB is equals to K delta X. So our K is 30 and our delta X is 2, so it becomes 60 newtons. Alright, and from this knowledge, we can actually draw the free body diagram, okay? So to draw the free body diagram, it's just, for a particle, it's simply just a point, right? And of course, since the spring is extending, we can take consideration this force is actually pulling the particle towards, right? So we know that this is 60 newtons, okay? And we can draw this triangle here, this Pythagoras triangle right here. We can draw a small triangle. That this is a 3 to 4 triangle, right? And that means it will be 5 here, obviously, okay? That's for AB. And then we have another force right here, okay? And this is also pulling the spring towards, it's AC. So that's FAB here. I'm going to write here FAB. FAC, we don't know the force. But what I do know is that it's a 3 by 3. Okay, so it's a 3 by 3 triangle. So meaning to say that if you were to square 3 squared plus 3 squared, it would be a 3 root 2. Okay, that's what we know. And we know that this is FAD that's pulling the particle downwards. Okay, FAD. So if we take into our direction sense that positive x is going to the right, y is going to the top, okay, then eventually we'll be able to find out FAC and FAD. And the question really wanted us to find the mass of block at D, so a block at D is related to this force FAD, of course, right? So, and we take the summation of Fx to be equals to 0, okay, where given that x is positive. So we know that 60 times 4 over 5, okay, that is obviously positive, minus, minus 3 over 3 root 2 FAC, okay, that is equivalent to 0. So you get here 60 times 4 over 5 would be 60 times 4 over 5 would be 48. Alright, so 48 equals to 1 over root 2 FAC. Okay, because 3 over 3 root 2, if you simplify it, will obviously be 1 over root 2, right? If you divide it by 3, and if you divide it by 3, okay, so automatically your FAC would be 48 root 2 newtons. Okay, so that's your FAC. Cool. So now we can easily find our FAD if we take the summation of Fy to become 0. Okay, so in this case we'd have 60 times 3 over 5, which is obviously going upwards, plus 3 over 3 root 2, or 1 over root 2 if you like, 1 over root 2 FAC, okay, minus FAD equals to 0. So 60 times 3 over 5 plus 1 over root 2 times your FAC, which was 48 over root 2 as we got earlier. Okay, so we'll end up having 84 minus FAD equals 0. So FAD is just 84 Newton. Alright, cool. So we already know the FAD is 84 Newton. So what I'm going to do now is to draw another free body diagram. Okay, so we're going to draw another free body diagram of the block itself. So this is a block at D8 question. Okay, so this is FAD, which is equals to 84 Newton, and the block's weight itself, right, the weight of the block, which is W equals to 9.81 M. Okay, and we take, of course, the convention where X positive is going to the right, Y positive is going to the left. So summation of it going upwards of Fy equals to 0 because the block is not moving, it's in equilibrium. So we know that 84 minus 9.81 M is equals to 0. Then 9.81 M equals to 84. Thus, M is equals to 84 divided by 9.81. Sorry, 9.1 would be 8.56. So the mass of the block is 8.56 kg. So yeah, that was it. Again, a fairly straightforward question if you know what you're doing and if you remember about the Hooke's law. So this is actually basically a recall of Hooke's law, by the way, and equilibrium equations, right, for 2D cases where summation of fx is 0, summation of fy is 0, then eventually you'll be able to get your answer related to mass. Okay, so that was all right. Now let's go on to question number 4. Question number 3, my bad, sorry. So replace the force system acting on the post by resultant force and specify where its line of action intersects the post AB measured from point B. Okay, so what it means by measured from point B is actually from this point right here. This point B right here, we have to find the resultant, basically we have to find the distance of that particular resultant force to point B. Okay, so how am I going to do this? First and foremost, we try to find the resultant force, and yeah, we can draw a simple free body diagram on this problem, by the way. So what we're gonna have here is we're gonna have the post AB. Oh, whoops, that was not really what I was intending to do, but let's just pretend it's the post. Okay, and this is obviously A and this is B, B, and I'm gonna draw a dashed line here, by the way, just to make things look a bit nicer. So this is, pretend it's a dashed line. Okay, so the question wants us to find this force. Okay, let's just pretend B is just some arbitrary oh my god, whoops, let's just pretend that B is just some arbitrary force. Okay, the question wants us to find the force. Okay, pretend this is force B, and they want to know the distance, okay, from point B itself, actually. So they want to know this distance. Okay, so it's what the question is asking us to do. So what we're going to do, of course, is that we're going to state the 3 equations of equilibrium, right? And remember, we'll take the conditions where X positive is going to the right, Y positive is going upwards. So the 3 equations of equilibrium are that summation of Fx is equals to 0, summation of oh, sorry. It's not equilibrium. My apologies. Sorry. Because this chapter 4 is not about equilibrium. So we're supposed to find the resultant force, actually, right? And moment at point B. Okay. So let's get on to it. So, oh, space and error, I guess. Let me delete this page first. Okay. And let me add a new page to it. Okay. All right. So what we're going to do is, of course, we're going to find the resultant force itself. So in the X direction. So resultant at the X direction would be what? In this case, the 300, right? The 300, that's going to be negative. So it'll be negative 300, right? And then the 250 Newton, if we were to resolve it into its components, it's actually going here for the x direction. So that's positive. So it's 250. So it's plus 250 times 4 out of 5. Okay, and then we have the 500 Newton force. If we resolve in the x direction, it's going negative. So it's just 500 cosine 30 plus 500, or minus, right? Minus is negative, so minus 500 cosine 30. Okay, so we do the addition. So 300 plus 250 over 5 minus 500 cosine 30. Okay, hold up. Okay, so let's add the other two first. So 300 plus 250 over 4 over 5 would be negative 100 minus cosine 30 is 3 over root 2 times 500, 250 root 3. Okay, so minus 250 root 3. So I'm going to leave it here, okay, and this will be in newtons. Then of course we find the y component or the resultant force itself. So that means summation of Fy resultant. And there's only going to be two components, okay? One is from the 250 Newton that is going downwards, so that's going to be negative. Another one is from the 500 Newton that's going upwards, so that would be positive. So it would be, in this case, negative 250 times 3 over 5. Okay, negative 250 times 3 over 5 plus 500 sine 30. 100 sine 30. Okay, so negative 250 times 3 over 5 plus 500 sine 30. So it'll just be 100 newtons. Okay, it'll just be 100 newtons. So in this case, we found the resultant force, right? And now we can easily, in the x and y components, so the overall resultant force would be, using the Pythagoras theorem, okay, it would be fxr squared plus fyr squared. So of course you square these two components, what will you end up getting? Let's see. So negative 100 minus 250 root 3 squared plus 100 squared. How much will we end up getting? So we end up getting 542.31 42.3122 newtons, right? We end up getting that. So they wanted the resultant force, obviously, right? We want the resultant force. So in three significant figures, that would have been 542 newtons. Oh wow, I'm sorry, I think it's just my let's see, what's the problem? Okay, I think that was just my app glitching just now. Apologize for that. So yeah, 542 newtons. Okay, now we want to know the direction that's acting on. Okay, so in this case we already know, yeah, Fy is obviously upwards, right? The Fy, a resultant, is going upwards in the y component, and in the x component it's going in the negative direction, right? So this is Fx, and this is our resultant, right? So this is Fr. So I want to know the angle that acts vertical, and we'll call this alpha. So alpha basically is the cosine inverse of 100, oh wow, 100 over, okay, let me just make sure it's correct. It's just 100 over 500 542.3122. Okay, and as you find the angle for it, it's just 100 over 542.3122. It would be 79.4 degrees upwards. Okay, so it's gonna be 79, wow, 4 degrees. So it would be kind of like this, yeah, like we found the angle rate for alpha, right? So alpha is 79.4 degrees. Okay, so that's the resultant force already. You got the force and the direct magnitude and the direction, but we need to also find the distance. We need to find what is the dB, right? How are we going to do that? Well, the best way to do it is to take the moment at point B, right? Because the question strictly wanted at point B. So let's take the moment at point B, right? And well, okay, let me delete this. Okay, so the moment at point B. So let's say the moment at point B when counterclockwise is positive. In this case, let's see, from each of the forces. So for the 300 Newton force, okay, it only has one distance from moment point B, which is just 1 meter plus 1 meter. That would give me 2 meters, and it's going in a clockwise direction, so therefore be negative. So it would be negative 300 times 2. Okay, cool. So that's the first force done. Now for the second force. The second force, actually 250 newtons, it only has a distance of 0.5 meters from B, right? So that means its x component, it's on the same line, it will not generate any moment. But the y component of this 250 newton force will generate a moment because it's perpendicular, right? So you'll create this clockwise motion as well. So it's 0.5 times the vertical component of the 250 meter force, and that's clockwise, so it'll be negative. So in this case, we're gonna take it as minus 250 times 3 over 5 times 0.5. So it'll be times 3 over 5, that will be the force, right, with its components, and 0.5, which is the distance. Okay, now the last force right here, okay, from B itself, it has a distance of 1 meters. So the vertical component will take effect, right? The horizontal component will take effect. Okay, and this is related to 1 meters itself. And yeah, this would create the moment. This will go in the clockwise direction as well, because you see this force, when it's from B that's perpendicular, it will create this clockwise moment. And for the vertical one, actually the vertical one is in line with the line of action itself. So since it's in line with the line of action itself, therefore there is no moment actually from B to that particular force in the vertical direction. So it's also negative, so we're going to put a negative sign. So it's negative 500 cosine 30, right? Times with 1 meters. Okay, so times with 1 meters, right? So okay, how much do we end up getting? So it's just negative 300 times 2 minus 250 times 3 over 5 times 0.5 minus 500 cosine 30 times 1. So yeah, we end up getting negative 1108.0127 Newton meters. So this of course refers to the fact that it's going clockwise, basically. So this is the clockwise resultant moment. Now we wanted to find the distance d, okay? So to find the distance db, it is just simply mb divided by fr, right? So 1108.0127, okay, divided by fr, which was in this case our fr actually has two components also, right? And this is quite tricky, by the way. So this is a very interesting problem, because now we are dealing with a problem where our fr could be having a horizontal vertical, but as we've seen earlier, right, for component forces, right, as you've seen earlier for component forces, Usually we don't consider vertical because the vertical actually will be in line with the line of action itself. So since it will be in line with the line of action itself, it will not generate a moment at point B. Thus the horizontal is the only one that's going to generate the moment itself. Well, actually, for the case 250 Newton, the vertical did generate the moment itself. So, yeah, that's the question here. Okay. So, let's see. So, let's take FR in terms of Fx, which is negative here. So, oops, sorry. Let's put the negative sign. We take the Fx would be negative 100 minus 250 root 3. Let's see what we end up getting. We get about 2.07 2.08 meters. Okay, this is only Fx component considered. Okay, and if we are to consider the Fy component, for instance, so I'm going to put here Frx. So let's see, what about the Y component? Will it generate any moment or not? Let's see. Because the Y is positive, I doubt it will actually. But let's see. Okay, so I'm having a bit of trouble writing, but 0.00127 over 100 newtons. So when we divide it, obviously with 100 newtons, we'll end up having negative 11. Negative 11 wouldn't make any sense, right? Because first of all, why would it not make sense actually is that our bar, the length is 1 meter, right? That's vertical. 1 meter, 1 meter, 1 meter. So it would be total, it would be 3 meters, right? So it'll be 3 meters right here, vertically. And our resultant force FB is going to be acting upwards. So there's no way you can generate a moment up there. And here, from the line of action B to this point is 0.5. So we're quite limited, actually. Therefore, we don't consider this. We don't consider the Fy case, right? At all. So if we were to draw the free body diagram again of the same problem, and I just simply draw this right here, just draw this, okay? So our resultant force would look something like this, okay? It would look something like this. This is our Fr, okay? And the angle it makes, oh, wow, the angle it makes is 79.4 degrees. 79.4 degrees, okay? So 79.4 degrees. And the distance it would make actually would be 2.08 meters. So yeah, that's basically it. So this is our distance right here, okay? Okay, this is our Fr, and this is our angle. So apparently my tab's been glitching for some time, so I do apologize actually for the technical issues that I've been facing. I am not sure whether it's the app issue. I believe it's the app because, yeah, the app is being a bit troublesome. But anyways, so that's how we tackle for this question right here. We already found the resultant force as needed. We found the direction resultant force, and we found the distance actually from the line of action itself, right? So yeah, hopefully that's it. Now we're going to the last question before we end this simulation. So this member is supported by a square rod, okay, which is then which fits loosely through the smooth square hole. So this is very important, the word loosely through the smooth square hole. Okay. Attached to the collar A and by the roller at B. Determine the components of reaction at these supports when the member is subjected to the loading as shown. Okay, so when the member is subjected to the loading as shown. So first of all, the very first important thing is to draw the free body diagram. Okay, to obviously draw the free body diagram of the system itself. So I'm gonna draw with the axes, right? So X, Y, and Z. Okay. Okay, so I'm gonna draw it again. Okay. So X, Y, and Z axis. Okay. So I'm going to use a different color. We're gonna draw this particular object. So it's gonna look something like this. Okay, this is our object right here in question. So what do we know about this object? We know it has three loadings, okay, one parallel to each axis. So this is 300 Newton meter is pointing towards the x-axis. And we know that this 500 Newton meter is pointing to the y-axis, the positive y-axis. And we know this 400 Newton meter is, well, going downwards, okay. And one thing we know is that there's a support reaction at B due to a roller, which is going to be obviously FB. And at A, since it's a smooth square rod, so there are going to be a few limitations. First of all, okay, it cannot move by the y direction, right? It's not movable at all. Second of all, it cannot also move by the x direction as well, okay. Then there's also the restriction that it cannot rotate. So that means that the moment vector, okay, at MAX also there's a support reaction, and thus at MAY also there's a support reaction, okay. And for MZ, actually it cannot rotate because it's a square rod, so there's also going to be a support reaction as well, right? So this is a MAZ, but it can move up and down, so therefore there's going to be only 5 support reactions, right? So it'll be 1, 2, 3, 4, 5, and of course 6. So therefore we have 6 support reactions. So meaning to say that this problem is statically determinate. It means we can solve this problem. There's no problem, there's no issue at all. Okay, let me just change the color. I'm using red. Okay, all right, let's mark this with blue. 2 meters, 1 meters, and 2 meters. Okay, so let's try to find the support reaction problems. First and foremost, okay, I think there's some glitch here. It's been affecting my iPad for some time. Right. Okay. So let's write down the equations of equilibrium. Okay, so the equations of equilibrium. So for the equation of equilibrium, okay, we have that summation of fx is equal to 0, summation of fy equals to 0, summation of fz is equal to 0, summation of mx is equal to 0, summation of my equals to 0, and summation of mz is equal to 0. We have 6 equations of equilibrium, and like I said before, we have 1, 2, 3, 4, 5, 6 unknowns. So yeah, we can solve this problem, no problem at all whatsoever. So let's proceed. I think we can easily determine for FB. Okay, so let's focus on it. So when summation of fz is equal to 0, or let's just put it like this. So let's just take fz equals to 0. So fz is equal to 0, all right. So we know that FB is going in the positive direction, so that's going to be a plus. And we know that there is no support at A itself, right? There's no support, clearly no support at A. But there is one at FB, and then there's a force of 400 Newton that's going downwards. So we minus with 400. Okay, 0. So FB is equals to 400 Newtons, right? It's going upwards in the Z directions. Okay, so that's your magnitude of the, that's for FB. We already found the loading at B. It's a very simple loading. Okay, then for FAY also I think should be pretty straightforward. Let's tackle it. So summation of FY equals to 0. So the only loading I see here is the 500 newtons. So that is 500 newton positive. Okay. And we can see FAY is positive, yes, because there's no other reaction forces. So FY is positive. So plus FAY equals 0. So therefore FAY would be negative 500 newtons. So meaning to say that it's going in the opposite direction, right? It's going in the negative Y direction. All right. Then for FAX, okay, summation of Fx equals to 0. We can see that 300 newtons is going the positive direction. So 300 newtons is going the positive direction, and FAX also is going the positive direction as well. So it's going to be plusing FAX. It's equals to 0. So therefore FAX equals to negative 300 Newton. Okay. So basically it's going in the negative direction. Alright, so we've already found 3 of our unknowns. But we still have 3 left. We still do not know what is MAY, what is MAX, and MAZ. Okay, so how are we going to find it? Well, pretty simple. Let's start with MAZ first. MAX first. Okay. Right. Let's see. Okay. Wow. Alright. Okay. Maybe it was a bit of a glitch there. Okay, so let's start with MX. The summation of MX is equals to 0. Okay, for equilibrium. So this one is where I want you guys to utilize your right hand rule. Remember in class that I've mentioned, okay, if you remember this circle, yeah, I, J, K, okay, the cross product, right? So I cross product J would give you K, K cross product I will give you J, and J cross product K will give you I. Because remember that the moment vector is always the cross product of R cross product F, right? The cross product of 2 vectors. So this is basically the relationship that you should remember. So for mx is 0, so for mx is equals to 0, we have to find the force that's either in J or K and the distance that's also within the J or K component. So here we can see that there's 500 Newton, right? Let me use a different color. In green, okay. So it's 500 Newton here, okay. In the y-axis, and then there is 2 meter here in the j-axis, okay, which is obviously going to give us a vector in the x direction, right? And in this case it's going counterclockwise, so we'll take into consideration, right? So I'm going to put in positive, so it would be 500 times 2. Okay, that's positive, right? Then let's see, we also have another force here I've noticed, 400 Newton. Okay, that's acting in the K direction. And yeah, unfortunately there is no other distance acting in the Y direction at all, because all the distances are actually along the X axis itself, so therefore they will not generate any moment along the what do you call it, along the X axis at all, right? Because the distances are lying on the X axis, and then of course this 400 Newton and this 2 meter will not generate any moment at all. So the only moment that we see that can be generated is the 500 Newton and the 2 meter earlier that we highlighted earlier. Okay, they will only generate a moment along the x-axis itself, right? So basically they'll generate this moment right here. Okay, so yeah, so I think that's about it. And MAX, okay, so plus MAX equals to 0. So therefore the moment vector, okay, it becomes negative 1000. Okay, 1000 Newton meter, meaning to say it's going in the opposite direction as intended. Now for the summation of my to be equals to 0, okay, so we already found all this. So summation of my, so for may, again, we need to either find a vector that is going in the z-axis or in the x-axis, okay, for the force and for the distance. So I find a force here, 400 Newton, that is going in the z-axis, and the distance in the x-axis, it's 1 meter plus 2 meters, so it's obviously going to be a total of 3 meters, and it's going to be counterclockwise, so it's going to be positive. So it's 400 times 3, so that'll be a positive number. 400 times 3, so it's positive. Okay, besides that, this 300 Newton also, it's also in the x-axis, and the 2 meters in the z-axis, so this one also is going to create a moment, okay, along the y-axis, and this is going in a clockwise direction along the y-axis, okay, and as a result it'll be negative, so it'll be negative 300 times 2. Okay, any more forces? Yeah, there is one more force I actually haven't considered. 500 Newton is going in the y-axis, so it will not create a moment there. But for FB, okay, FB, the force supported B, if you multiply by 2, it will of course be creating a moment along the y-axis itself, and it's going to be clockwise, so it's negative. So it's negative FB, so FB in this case was 400, so negative 400 times with 2. Right, so negative 400 times with 2, and don't forget to plus it with MAY equals to 0. So it's 400 times 3 minus 300 times 2 minus 400 times 2. So we minus 200. So minus 200 plus MAY equals 0. So therefore MAY should be 200 Newton meters. Okay, so that is your MAY. Now the last but not the least is your MZ. So your MZ will be equal to 0. So in this case, there's only gonna be, you have to have a force either in the x or in the y component, as well as the distance to be in the x or y component. So for 300 newtons, right, 300 Newton itself, it won't be able to generate a moment along the z-axis, because the thing is, the only distance is this 2 meters, which is obviously along the z-axis, so that's not possible. And the 1 meter and the 2 meters, which are along the x-axis, will not generate any moment, so we can't take that in consideration. 400 newtons is going to z-axis, is not possible. So 500 newtons actually can, because this 500 newton is pointing towards the y direction, but it has a distance along the x-axis, which is just 1 meter and 2 meters. So it will actually be rotating along the z direction, and it's gonna be, oh sorry, let me undo that. It's gonna be in clockwise, yeah. Sorry, it's not going clockwise. It's gonna be in counterclockwise actually. Okay, so it's going in a counterclockwise direction. So therefore, be positive. So be 500 times with 3 positive plus MAZ equals 0. So MAZ will be negative 1500 Newton meters. Okay, so be negative because you'll counteract it. So yeah, that's basically it. That's how we have found out the 6 unknown support reactions: FB, FAY, FAX, MAX, MAY, and MAZ. Okay, so yeah, that's about it for the simulation. So I hope you guys could actually understand how to deal and tackle with problems like this, right? And how to solve it within a given time. Again, I'm not sure of how many questions will be there in test 2, whether it will be 3 or 4 questions. Probably 3, I guess. But I just give 4 so that you practice each of the chapters evenly, like chapter 5, chapter 4, chapter 3, and chapter 2. Right? So yeah, this is chapter 2. I forgot to highlight that. So yeah, hopefully this simulation is gonna be helpful for your test 2 tomorrow, inshallah. Test 2 on Thursday, inshallah. Right, assalamu alaikum.